Right, this lesson is about expanding binomial series. A grade E student should be able to expand 1 plus x to the power of n. Grade C students will be able to find particular terms in the expansion of 1 plus x to the power of n, and whereas grade A students will be able to find a binomial expansion of more complicated functions by adding, subtracting, multiplying, dividing binomial series of other functions. Section 6, Binomial Series, 1 plus x to the power of n, on page 14 of the C4 notes. From C2, 1 plus x to the power of n equals 1 plus n choose 1 of x, plus n choose 2 of x squared, plus ... plus n choose r of x to the r, plus ... plus x to the power of n, which equals 1 plus n times x, plus n times n minus 1 over 2 factorial x squared plus ... plus n times n minus 1 ... n minus r plus 1 over r factorial plus ... plus x to the power of n. And this is true for any natural number n. Now this can be extended to any rational number n, a rational number being any number that can be represented as a fraction. So this will include negative numbers as well. So 1 plus x to the power of n equals 1 plus nx plus n times n minus 1 over 2 factorial x squared plus n times n minus 1 times n minus 2 over 3 factorial x cubed plus, and we just carry that pattern on forever, so plus ... Have this infinite series only converges when the modulus of x is less than 1. It must be pointed out, however, these formulae are in the formula booklet. So given the modulus of x is less than 1, expand and extending powers of x up to and including terms of x cubed, 1 plus x to the power of minus 1. So in this case the n is equal to minus 1. So we get 1 plus minus 1 times x plus minus 1 times minus 2, as in n minus 1, minus 1 minus 1 is minus 2, all over 2 factorial x squared plus minus 1 times minus 2, and then it's n minus 2, so minus 1 take away 2 is minus 3, so we're always times by a number 1 less than what we've got already, all over 3 factorial x cubed plus ... And we can use our calculators if necessary to simplify. So minus 1 times x is just minus x. Minus 1 times minus 2 is 2. Divide by 2 factorial gives us 1, so it's plus x squared. Minus 1 times minus 2 times minus 3 is equal to minus 6 over 3 factorial equals minus 1, so we get minus x cubed plus ... That's our binomial expansion. Now in part B we're doing 1 minus x to the minus 1. In this case our x, so I like to put inverted commas, is minus x. So wherever x comes in the formula we're going to put minus x there instead. N is still equal to minus 1. And we use the same formula, so 1 plus nx becomes 1 plus minus 1 times minus x plus minus 1 times 1 less than minus 1, minus 2 over 2 factorial times minus x all squared plus minus 1 times minus 2 times 1 less again, minus 3, all over 3 factorial times minus x all cubed plus dot 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 equals 1. Minus 1 times minus x is plus x, so it's 1 plus x. Minus 1 times minus 2 is 2, over 2 factorial is 1, so we get plus minus x all squared is x squared. We get minus 1 times minus 2 times minus 3, which is minus 6, divided by 3 factorial is minus 1. Minus x all cubed is minus x cubed, so minus times a minus gives us plus x cubed. Plus dot dot dot. And in this case, 1 minus x to minus 2, our x, again inverted commas, is actually minus x. Our n this time is minus 2. So sticking to the formula, 1 plus nx, 1 plus minus 2 times minus x, plus minus 2 times 1 less, minus 2 times minus 3, over 2 factorial minus x squared plus minus 2 times minus 3 times 1 less, which is minus 4, over 3 factorial minus x all cubed plus dot dot dot. So simplifying, minus 2 times minus x is plus 2x. Minus 2 times minus 3 is 6, over 2 factorial is 3. Minus x all squared is x squared, so we get plus 3x squared. Minus 2 times minus 3 times minus 4 gives us a minus 24, over 3 factorial gives us 4, minus 4. Minus x all cubed is minus x cubed, so the minuses cancel to give a plus, and we get plus 4x cubed plus dot dot dot. Now things get harder when we have something other than plus x or minus x, and certainly fractions also cause their own complication. So our x in this case is 2x, for 1 plus 2x to 3 over 2. Our n is 3 over 2. So sticking to the formula, 1 plus nx, 1 plus 3 over 2 times 2x plus n times n minus 1, so 3 over 2 times a half for 2 factorial times 2x all squared plus 3 over 2 times a half times 1 less, so minus a half over 3 factorial times 2x cubed plus dot dot dot. Calculating, 3 over 2 times 2, 2's cancel, we get a 3, so 1 plus 3x 3 over 2 times a half is 3/4, over 2 factorial is 3/8. 2x all squared is 4x squared. So 3/8 of 4 is 3 over 2. X squared. Then next term, 3 over 2 times a half times minus half, all over 3 factorial, times the 2 cubed. So a common error here is in the brackets, because it's 2x all cubed, you have to cube the 2 as well as the x, just as we had to square the 2 as well as the x in the previous term. Now in this case, using a calculator, we're going to get minus a half x cubed plus dot dot dot. So that's the expansion. Apologies for the poor writing. Now we're also asked to state the values of x which the expression is valid. Now usually it's the modulus of the x as part of the formula, so the is less than 1. In this case we haven't got x, we've got 2x, it's the modulus of 2x that's less than 1. And so dividing both sides by 2, the modulus of x is less than a half. So the only values for which this expression is valid is when the modulus of x is less than a half. Now we also need 1 minus 3x to the minus 2/3 for the second part. So in this case our x is minus 3x, our m is minus 2/3. So sticking it into the formula, 1 plus nx is minus 2/3 times minus 3x plus n times n minus 1 so that's minus 2/3. 1 less than minus 2/3 is minus 5/3 over 2 factorial minus 3x all squared. The next term, minus 2/3 times minus 5/3 times 1 less is minus 8/3 all over 3 factorial times minus 3x all cubed plus dot dot dot. Multiplying out, minus times minuses are, we've got 1, minus times the minuses are plus, the 3's cancel so we get plus 2x. Moving on to the next term, minus 3x all squared would give us 9x squared, times into minus 2/3 times minus 5/3 all over 2 factorial, we're going to get 5x squared. Next term, minus 3x all cubed will give us minus 27x cubed. So all the minuses will cancel out, so we'll get plus. Cancelled. If we stick it all into calculator, we'll get 40 over 3 x cubed plus dot dot dot. So that's the expansion. Again, for the validity, our x has to be less than 1. In this case our x is minus 3x. But because of the modulus, that's the same as just saying the modulus of 3x is less than 1. And therefore the modulus of x is less than 1/3. And that concludes the presentation.